So in this chapter we have to cover some topics. The topics are at the first topic is introduction. Second is properties of light. What are the properties of light? After that, we have to talk about the reflection, laws of reflection, virtual and real image. Next is image formed by plane mirror. Next is characteristics of image formed by plane mirror. Okay, we know very well what is plane mirror. Plane mirror is something like this. Okay, its one surface is well polished and other surface is reflecting. This surface is polished. This surface is polished and this surface is reflecting. This surface is reflecting. Okay, so this is known as plane mirror. Okay. Now, lateral inversion and its application. Spherical mirror is what? There are two types of spherical mirror. I have told you before. How many types of spherical mirror? There are two types of spherical mirror. First is concave. Yeah. And second one is convex. Okay. Next is the property of concave mirror, properties of convex mirror. So common terms for spherical mirror means common terms means what? What is U? What is V? What is F? Okay. All the distances are taken from the pole of mirror. F is the focal length of the mirror. U is the distance of object from the pole of mirror. V is the distance of image from the pole of mirror. Okay. So okay, now, so rules for making a ray diagram by spherical mirror. What are the rules? Rules means what? When object is placed in between the focus and pole of mirror. Okay, so where will the image form? And next case is when object is placed between the focus and the center of curvature. Now, where is the image form? What is the location of image formed? Okay. Next one is when object is kept at the focus. At the focus. So where can be image formed? Next case is when the object is kept at the center of curvature. So now when where will the object or image is formed? Now if object is placed beyond the center of curvature, now where will image the form? Where will image form? Okay. So these cases we have to study. Now ray diagram for image formed by concave mirror. Okay, so these are the cases in which we have to study about the location of the image. When the object is placed at infinity beyond center of curvature, at center of curvature, placed between F and C means focal length and center of curvature. So next is placed at F between P and F. What is P? What is P? I've told you before in the previous lecture. What is
Pole.
P? Pole. Very nice. Very good. Pole. Okay, and F the focus. Okay. So now uses of concave mirror. What are the uses of concave mirror? Okay. Ray diagram of image formed by convex mirror. What is the ray diagram? How ray diagram is formed for the convex mirror? There are only two cases. Okay. So these are two cases when object is placed at infinity and when object is placed between pole and infinity. Okay. There are two cases only in a convex mirror. Next is the uses of convex mirror. What are the uses of convex mirror? Sign convention. I have told you before about the sign convention. Let consider that this is axis. This is axis, and uh, this point is treated as pole. This point is treated as origin. That is known as pole or origin. So when you move in the right direction from the origin, so the all the quantities will be positive, and when you move in the at the left side of the origin, so all quantities will be negative. Okay, and this point O is treated as pole of mirror. Consider that we have a mirror. Okay, so which mirror is this? Can you tell me?
Concave mirror.
Concave mirror. Very nice. So consider that this is a concave mirror, and this line is known as principal axis. This line is known as principal axis. Okay. So if we talk about the pole, so this point is called pole. This blue color point is called pole. Okay. All the distances are taken from the pole because pole is treated as origin, And if we talk about the right side, the distance from the distance of the right side from the pole will be taken as positive, and the distance, all the distances at the left side of pole will be taken as negative. Okay. Now we have to study about the mirror formula, what is mirror formula, and magnification of spherical mirror. So these are the topics in this chapter which we have to cover. Is it okay or not?
Yes, sir.
Okay. Now after that, we'll talk further.
सर मिरर फॉर्मूला एंड
हम्म,
मैग्निफिकेशन ऑफ स्फेरिकल मिरर ये तो कर लिया था.
हाँ ये अपन कर चुके हैं. ओके. मैं एक्चुअली में क्या था, एक सेकंड में बताता हूँ. if we yeah, if we talk about the properties of light, so electromagnetic waves so does not require any medium to travel. Actually there are two types of waves. Okay, actually there are two types of waves. Okay, first is electromagnetic wave, and the second is mechanical wave. Second is mechanical wave. There are two types of waves. Okay, electromagnetic waves are those waves which don't require any medium to travel. Okay, but mechanical waves are those waves which require any medium to travel. Without any medium, they can't travel. Okay, without any medium, they cannot travel. So we can write this: without without any medium, without any medium, they cannot travel. They cannot travel. Okay, but there is no requirement of medium in electromagnetic wave. Okay, electromagnetic wave can travel without any medium. Okay, जैसे आपने देखा होगा सन से जो रेज आती हैं. ओके, सन से जो रेज आती हैं तो वो जब सन से जो रेज आ रही हैं तो वो तो यार सन पता नहीं कहाँ पे है, तो वहां पे कोई मीडियम थोड़ी है. देयर इज नो मीडियम ना. बट द रेज आर कमिंग टू अर्थ and coming to all over universe. Okay, so we can say that these rays are known as electromagnetic wave. These waves are known as electromagnetic wave because they don't require any medium to travel. Okay, so now if we talk about the mechanical wave, so there are two types of mechanical wave. Again, there are two types of mechanical wave. First is a transverse wave. First is transverse wave, and second one is longitudinal wave. First is transverse wave and the second one is longitudinal wave. Okay. So mechanical wave is what? Mechanical wave is what? Give me answer. Mechanical
Which
wave is what?
travel without any medium.
Yeah. They don't require any medium to travel. Sorry. They require any medium to travel. They require any medium to travel. But if we talk about the electromagnetic wave, so they don't require any medium to travel. Okay. So we can say that if we talk about light, so I have written that electromagnetic wave. Light is the electromagnetic wave, so doesn't require any medium to travel. Okay. Now second point is light tends to travel in a straight line. Okay. You have never seen that light is moving something like this. Light moves only in the straight line. It covers the straight line path. Something like this, a straight line. Whenever light will move, this will cover a straight line path. This is a straight line path. Light don't move something like this. Okay, this is not light, this is a wave. Okay. Okay, now in the next point we'll discuss about the light has dual nature, that is wave as well as particle. Okay, light has two nature. It is a wave as well as it is a particle. Okay, next is light cast shadow. Shadow तो बनाती है, ये तो आपको पता है. Next is speed of light is maximum in vacuum. It is a 3. What is the speed of light? I'm writing here. What is the speed of light in vacuum? It is denoted by C. Okay. So the value of C is 3 into 10 raised to power 8 meter per second. This is the value of speed of light in vacuum or air. Okay, vacuum or air. So this is the speed of light, 3 into 10 raised to power 8 meter per second. Meter per second is the unit of speed. Okay. So the speed of light is maximum in vacuum. Vacuum से मैं maximum है, इससे ज़्यादा नहीं हो सकता कहीं भी. That is 3 into 10 raised to power 8 meter per second. Okay.
Yes, sir.
Now, when light falls on a surface, following may happen. Up when any light ray is incidenting on a surface, okay, so some phenomena will occur. So which phenomena? Reflection takes place, refraction takes place, and absorption takes place. Okay. So if we talk about that this is a surface on which any light rays falling. Consider that this is a normal. So any light rays falling, some part is reflected, some part is refracted, and some part is absorbed by the surface because the surface will get heated. सरफेस गर्म हो जाती है.
Yes, sir.
तो इसका मतलब है कि उसने कोई ना कोई पार्ट एब्जॉर्ब किया होगा. ठीक है. लेकिन जो हम लोग पढ़ते हैं ना कि हम लोग रिफ्लेक्शन अलग से पढ़ लेते हैं, रिफ्रैक्शन अलग से पढ़ लेते हैं, ये यार आइडियल होता है. आप कैसी भी सरफेस ले लो, आप पॉलिश जो सरफेस भी अगर लोगे तो कुछ ना कुछ पार्ट उसका रिफ्रैक्ट होता है, दूसरे मीडियम में जाता है, कुछ ना कुछ पार्ट वो सरफेस ने एब्जॉर्ब किया होगा. कंप्लीटली रिफ्लेक्शन नहीं होता कि लाइट आई और कंप्लीटली लौट गई वापस, ऐसा कभी नहीं होता. भाई हो सकता है कि दूसरे मीडियम में नहीं भी गई हो लाइट, लेकिन उस सरफेस ने कोई ना कोई लाइट को एब्जॉर्ब जरूर किया हो. ओके. बिकॉज
Yes,
दैट सरफेस विल गेट इट हीट, गर्म हो जाती है, उसका टेम्परेचर इंक्रीज हो जाता है. इज इट ओके और नॉट?
yes, sir.
ओके. So now we'll talk about our next topic. So the next topic is, so this is our reflection. Okay, actually I have told you before what is reflection and how reflection does work. So reflection is nothing but the bouncing back of light when it is strike on a polished surface like mirror. So this surface is known as mirror, and this surface is also known as reflecting surface. This surface is also known as reflecting surface. This is also known as reflecting surface. Okay. And all, or what can we say, or what can we say, what is the name of the surface? Plane mirror.
Yes, sir.
Okay. प्लेन मिरर जो हमारे घरों में होते हैं ना, हम जिसमें फेस देखते हैं अपने. So these are the plane mirrors. Now what are the losses of reflection? First is angle of incidence is equal to the angle of reflection. Now I have told you before that this angle is called angle of incidence. The angle between incident ray and normal, that is called angle of incidence, and the angle between reflected ray and normal, so that is called angle of reflection. Okay. So
Yes,
in the law of reflection, so the first law is angle of incidence, that is angle I. Okay. So it is equal to angle of reflection. Angle of reflection means what? R. So we can say that I is equal to R. Okay. Now if we talk about the second law, the incident ray means this light. Incident ray means this light. Reflected ray means this light, this ray. And normal at the point of incidence, normal means what? This dotted line. Normal means what? This dotted line. Okay. All lie in the same plane. These are all in the same plane. Actually your screen is a plane. Your screen in which you are watching this diagram, that is a plane. Okay.
yes, sir.
So we are seeing that incident ray and reflected ray and normal all in the same plane, because all is in the in your screen you can see that. Okay. So these are the two laws of reflection. These are the two laws of reflection. And what is reflection? I have told that. Or we can say that the phenomena to change the path of light. Okay, I'm writing this. The phenomena to change the path of light without any medium, without change in medium. Na? The phenomena, the phenomena, the phenomena to change the path of light, the phenomena to change the path of light without change in medium, without change in medium. Okay, without change in medium. So this is known as reflection of light. This is known as reflection of light because actually we are taking the reflection. So we are seeing in this diagram that the medium of the light does not change. Medium is not changing here because the light falls at this point and reflect in the same medium, bounce back in the same medium. Okay, but this light is not changing the medium. If this light come in will come in this medium here, so we can say that the light is coming to that another medium. That means I mean to say that मतलब लाइट ने अपना पाथ दूसरे मीडियम में जा रही है, वो लाइट दूसरे मीडियम में मूव कर रही है, तो हम ऐसे बोल सकते हैं. Are you getting me or not?
Yes, sir.
Okay, so now I'll talk further. So there are some differences between virtual image and real image. There are some differences I have taken here. So image is a point where at least two light rays actually meet or appear to meet. When they actually meet, when they actually meet, that is called real image. When they actually meet, that is called real image. But when they are appearing to meet, that is called virtual image. They should not be meet in actual, so we can say that that is called virtual image. Is it okay?
Yes, sir.
So what is virtual image? Virtual image is that when two reflected or refracted light intersect each other or appear to intersect each other. Okay, if they are intersecting each other in real, that is called real image. But if they are appearing to intersect each other, if they are appearing not in real, appearing not in real, so that is called virtual image. Okay, now, so there are two types of images. First is a real image and second one is virtual image. So what is real image? Formed when light rays actually meet. Light rays actually meet. And virtual image is what? Formed when light rays appear to meet. Appear to meet is what? They are not intersecting or meeting in real. Okay, because if they are intersecting or meeting in real, so that is called real image, not virtual image. Second point is can be obtained on a screen. Can be obtained on a screen means what? Real image I can see, that is the real image, or we can see that it is formed on the screen. Actually all the images are formed on the screen. अगर आप मूवी देखने जाते हैं, मूवी देखने जाते हैं तो पीछे से वो प्रोजेक्टर आता है ना एक, वो कहाँ गिरता है? सामने. सामने क्या होता है? स्क्रीन ही तो होती है.
Yes, sir.
सामने स्क्रीन ही तो होती है जहाँ पे हम इमेज देखते हैं. अभी आप जैसे ये सब जो लिखा हुआ देख रहे हो, ये क्या है? स्क्रीन ही तो है.
Yes, sir.
समझ रहे हो ना? तो सारी इमेजेस बनती कहाँ है? स्क्रीन पे ही तो बनती हैं. ऑल द इमेजेस आर फॉर्म्ड ऑन द
ये
स्क्रीन.
पता
इफ
चलेगा कि वो इमेज है या वर्चुअल इमेज?
क्या हो गया?
देखकर कैसे पता चलेगा डिफरेंस इन दोनों इमेजेस के बीच?
नहीं नहीं, आप इसको पढ़ो ना, ये क्या लिखा है? कांट बी ऑब्टेन ऑन द स्क्रीन. वर्चुअल इमेज नेवर फॉर्म्ड ऑन द स्क्रीन. वो स्क्रीन पे बनती नहीं है, वो स्क्रीन पे बन ही नहीं पाएगी. ठीक है, क्यों नहीं बन पाएगी? क्योंकि वो मिलते हुए हमें अपीयर हो रही है. रियल में मीटिंग मीटिंग नहीं हो रही वो तो. दैट इज नॉट मीटिंग इन रियल. बट वी आर ड्रॉइंग द रे डायग्राम. वी आर ड्रॉइंग द रे डायग्राम फॉर आवर कन्वीनियंस. ओके, that is not meeting in real. Reflected light and refracted light are not meeting in real. If they are meeting in real, that is called real image, and the real image is formed on the screen. Okay.
Yes,
uh,
sir.
Wait for some time. After that, I'll discuss about the images formed. Okay, so that will be clear. Don't be tense, that will be clear. Everything is clear now. After that, if we talk about the real image, another property, inverted. When the image is real, that is always inverted. Now, what is the meaning of inverted? And if we talk about the virtual image, so virtual image is always erect. Now, tell me about the inverted and direct image. Meaning of the inverted and direct image.
Inverted images, um, the opposite diagram or drawing of the image.
Yeah, sure. Absolutely correct. Consider that this is a mirror. Okay, so this is a concave mirror. Okay, this is a concave mirror. Now, if this is a concave mirror, consider that the object is kept here. The object is kept here. I think that this color is not shown to you. Let me change the color now. This is object. Okay, this is object. Now, if the real image is formed, if the real image is formed of this object, so that will always be erect. Sorry, inverted. Inverted means this. Object is kept at the upper side of the principal axis, but the image will form in the downward direction. Object is kept, object is kept on the upward direction from the principal axis, and the image is formed at the downward direction from the principal axis. So that is known as inverted image. That is known as inverted image. Now, if we talk about the erect image, so what is the erect image? Erect image is nothing. Erect image is nothing but the image something like this. This is called erect image. Consider that this is object and this is image. So compare this object with this image. This image is erect because the image is in the same direction with the object. If object is in upward direction, so image is also in the upward direction. Okay,
Yes, sir.
are you getting me or not?
Yes, sir.
Okay, one more thing I want to say, that this is a polished surface. This side is a polished surface. Okay, so no light can pass through the surface. कोई भी लाइट अगर इस पे इंसिडेंट होगी तो क्या वो दूसरे मीडियम में जा पाएगी? क्योंकि उस साइड तो पॉलिश है. This side is well polished, so no light can pass through the medium. This light will impart here and reflect. No light will pass in this medium. But if तब भी यहाँ पे मान लो इमेज बन रही है, तो इमेज बनती कब है? जब दो लाइट एक दूसरे से मीट होते हैं. When two light will meet each other. ठीक है, बट कोई भी लाइट इस मीडियम में तो जा ही नहीं रही रियल में.
सर तो वो ट्रांसपेरेंट होएगा,
क्या क्या?
सॉलिड नहीं होएगा, फिर वो लाइट पास कर सकती है तो ट्रांसपेरेंट या ट्रांसलूसेंट.
नहीं, ट्रांसपेरेंट मीडियम नहीं है. दिस इज नॉट अ ट्रांसपेरेंट मीडियम ना. Actually, we are taking mirror. We are taking mirror. It's one surface. This surface is reflecting, and this surface is well polished. अच्छा चलो सुनो, आपके घर में मिरर है, प्लेन मिरर जिसमें हम फेस देखते हैं. अब उस पर आप ऐसे लाइट डालो, लाइट आपको दिखती है कि उस साइड जा रही?
नो सर.
नहीं दिखती ना. अगर हम तब भी उसकी इमेज बना दें, अगर हम अपने हिसाब से तब भी उसकी इमेज ऐसे रे डायग्राम से ड्रॉ कर दें, तो वो इमेज यार वर्चुअल कहलाएगी. दैट इमेज विल बी वर्चुअल because light is not going in that medium in real. लाइट रियल में नहीं जा रही ना. हमने देखा यहाँ से लाइट डाली, उस साइड से हम देख रहे हैं कि वो लाइट उस साइड जा ही नहीं रही, तो रियल में तो नहीं जा रही लाइट.
Yes, sir.
समझ पा रहे हो मैं क्या कह रहा हूँ?
Yes, sir.
मतलब इन शॉर्ट ये तो एक्सप्लेनेशन हुआ। इन शॉर्ट याद ये रखना है कि अगर पॉलिश्ड सरफेस की तरफ इमेज बने, ठीक है, अगर पॉलिश्ड सरफेस की तरफ इमेज बन रही है तो आप समझ जाना दैट इमेज इज वर्चुअल।
Yes, sir.
समझ जाओगे?
Yes,
दैट
sir.
इमेज इज ऑलवेज वर्चुअल if the image is formed at the polished surface. So I'm writing here, when image is formed, when image is formed, बोलो, at polished surface, or we can say that when image is formed at the side of polished surface, at the side of polished surface. Okay,
Yes, sir.
so this is called virtual image. This is called virtual image. Are you getting me or not?
Yes, sir.
Is it clear to you or not?
Yes, sir.
Okay, now the next part is example, image formed on the cinema screen and formed by concave mirror. अभी मैंने सिनेमा का ही बताया था कि हम जब मूवी देखने जाते हैं तो पीछे से वो आता है ऐसे, तो गिरता है सामने स्क्रीन पे। ओके,
Yes, sir.
एंड द सेकंड वन इज इमेज फॉर्म्ड बाय प्लेन मिरर बाय कॉन्वेक्स मिरर। क्लियर हो गया मेरे ख्याल से ये ना?
Yes, sir.
ओके, सो नाउ वील मूव फर्दर। So if we talk about the image formed by plane mirror, so at the first we'll talk about the image formed by plane mirror. So what is the image formed by plane mirror? Consider that this M dash is a plane mirror and AB is the object which is placed in front of the plane mirror, in front of the plane mirror. So one ray of light incident parallel to the principal axis. Okay, so this will pass through the medium. But how? Actually, we know very well that I is equal to R. I is equal to R. Okay, uh, let me explain one thing. This is a plane mirror. Okay, this is a plane mirror, and this is a normal. This is a plane mirror, and this line is called normal. Okay, consider that one ray of light is incidenting something like this. This is a light ray. Okay, wait. I am drawing in a proper way, completely. Consider that this light is incidenting on that medium. Okay. Now, what is the angle of incidence? Tell me about the angle of incidence.
Um, on the right side.
No, I'm saying I'm asking about the angle of incidence, the value of angle of incidence. What is the angle of incidence? Value.
90.
This is a very big mistake that you made and the student make. Okay, listen, listen, and very carefully.
Yes,
Okay,
sir.
I'm going to clear all your concepts. Consider that consider that this is a surface. Consider that this is a surface, and this is a normal. Okay, now any light is incidenting on the surface, something like this. Okay,
Yes.
so let this angle is theta. Let this angle should be theta. Okay, now if we talk about another light ray, something like this, is it shown to you or not?
Yes,
दिख
sir.
रही दिख रही ना? Okay, okay. So consider that this angle is alpha. Okay. Now
Yes,
tell
sir.
me the relation between theta and alpha. What is the relation between theta and alpha? Which is
Theta
greater?
plus
No,
alpha will
which is
equal to
which is which is
al-
greater? Which is greater? Theta and alpha. Which is greater?
um, both will be equal.
Um, how is this possible, यार? If theta and alpha are equal, तो यार
Okay, okay,
ये वाली
yes,
लाइट तो फिर यहीं से आती ना, ऐसे ही इसी के ऊपर से आती।
yes, sir.
तो इसमें थीटा ज्यादा है कि अल्फा ज्यादा है?
Theta,
थीटा इज ग्रेटर देन ना अल्फा।
yes, sir.
इज इट क्लियर नॉट और नॉट?
Yes,
तो ऐसा बोल सकते हैं कि जब लाइट जो है, ये लाइट ही तो है, ये पर्पल कलर वाला था, ये ब्लैक कलर से जो लाइट है, ये लाइट ही तो गिर रही है। लाइट इज फॉलिंग ऑन द सरफेस। यानी लाइट पहले यहाँ पे थी 1 मान लो, फिर ये यहाँ पहुंच गई। यानी लाइट जो है वो मिरर के पास जा रही है, मिरर के जो नॉर्मल है उसके पास जा रही है। येलो कलर से ये जो मैंने बनाया, ये क्या है? व्हाट इज दिस? दिस इज अ नॉर्मल।
normal, sir.
एंड लाइट इज गोइंग टुवर्ड्स नॉर्मल। So when light goes towards normal, angle becomes decrease. एंगल कम होता जा रहा है। पहले थीटा था, फिर अल्फा हो गया, अल्फा कम हो गया, अब और पास आएगी लाइट तो एंगल और कम हो जाएगा।
Yes, sir.
ठीक है। और जैसे ही और जैसे ही लाइट ऐसी आ गई, जैसे ही लाइट ऐसी आ गई, ठीक है, तो यहाँ पे एंगल कितना हो गया अभी बताओ? एंगल ऑफ
Z-
इंसिडेंस।
Zero.
देखो सारे एंगल हम लोग मेजर कहाँ से करते हैं? नॉर्मल से। ऑल द एंगल आर मेजर्ड फ्रॉम द नॉर्मल। And this light is parallel to the normal, so the angle between two parallel lines is always 0 degree. Are you getting me?
Yes, sir.
So we can say that angle of incidence is equal to 0. Angle of incidence is not 90 degree. Any problem?
No, sir.
ये क्लियर हुआ ना इतना? Is it clear?
Yes, sir.
Why angle of incidence is 0 degree and why angle of incidence is not 90?
Yes, sir.
Okay. So if angle of incidence is 0, so we can say that if I is equal to 0, then R is also equal to 0. Why? Because I equal to R.
Yes, sir.
Okay. So if angle of incidence is equal to 0, then R equal to 0. And I is equal to 0 means what? Light is incidenting parallel to the normal. Parallel to the normal. Consider that this is a mirror. Consider that this is a mirror, plane mirror. Okay. Listen here.
Yes, sir.
Consider that this is a plane mirror. Look at here.
Sir, yes.
Look at here. Look at here.
Yes, I'm watching you.
So consider that this is a plane mirror. Okay.
Yes,
And this is a normal. Okay. So any
yes,
light is passing, any light is incidenting on this plane mirror, parallel to the normal, parallel to the normal, parallel to the normal. Wait, I'm showing you by a pen. Okay. I have this pen. Consider that this is a incident ray and this is a normal, and my hand is a parallel surface. So this light is incidenting. This red light is incidenting parallel to the normal. Okay,
yes,
are you
sir.
getting me or not?
Yes, sir.
So this light, I'm talking about this light. This light makes theta equal to 0. Angle of incidence is 0 with the
Yes,
normal. Okay, and as we know that angle of incidence is equal to angle of reflection,
yes, sir.
and in this case, angle of incidence is 0 degree. So we can say that angle of reflection is also 0. So what is the meaning of angle of reflection is 0? That light retrace its path. Light retrace its path. When light will fall on the mirror, it retrace its path in the same medium. Okay, because we are dealing with reflection. We are dealing with reflection, so medium will not change. Okay, so we can say that.
Sir, but if angle of incident, the incident line isn't parallel to the normal, तब क्या होएगा? अगर वो ऐसे आ रही है और ऐसे जाएगी तो?
हाँ तो क्या दिक्कत है, अगर लाइट ये ऐसे आ रही है तो लाइट ऐसे चली जाएगी इधर, इस केस
Yes,
में भी। लेकिन ये जो एंगल है ना, आई इक्वल टू आर होगा, हमेशा होता है। ठीक है।
yes sir.
और यहाँ पे क्या हो जाएगा, ये लाइट ऐसे चली जाएगी वापस। मीन्स वी कैन से दैट लाइट रिट्रेस इट्स पाथ। रिट्रेस मीन्स व्हाट, मीन जैसे जैसे आई थी वैसे वैसे चली गई, सेम टू सेम पाथ पे अपने वापस चली, उसने अपने पाथ को दोबारा से ट्रेस किया। तो वही चीज यहाँ पे हो रही है कि यहाँ पे ये लाइट इंसिडेंट हुई, देखना यहाँ पे ए पॉइंट से ये लाइट इंसिडेंट हुई इस तरह से। अब ये कैसे लाइट इंसिडेंट, बताओ इसमें एंगल ऑफ इंसिडेंस कितना है इस केस में, एंगल ऑफ
Uh,
इंसिडेंस कितना है?
180.
नो नो, अरे मैं इस लाइट की बात कर रहा हूँ, जो रेड कलर से लाइट दिखाई दे रही है, एम एम डैश सरफेस पे ये इंसिडेंट हो रही है, तो ये इंसिडेंट एंगल कितना है? बिकॉज दिस लाइन इज पैरेलल टू द नॉर्मल ना।
Um, 0.
0 degree. So if angle of incidence is 0 degree, so what can she say about the angle of reflection?
It
what
will be,
what is angle of reflection in this case? That is also zero na.
yes sir.
And if angle of reflection is zero, that means light retrace its path.
Yes sir.
So if light retrace its path, so something like this, it will become like this. Means उसी उस वैसी चलेगी वापस, वैसी चलेगी वापस वो। Are you getting me or not?
Yes sir.
Okay. Now if we talk about another ray of light, if we talk about the another ray of light, and the ray of light is incidenting something like this light. Okay, this is the case which you have asked me. आपने अभी ये पूछा था ना कि सर अगर वो किसी एंगल पे आएगी तो क्या होगा, तो वो एंगल पे चली जाएगी ना, ऐसे एंगल पे आई थी और ये देखो एंगल पे चली गई। तो अभी ये वही तो हो रहा है कि ये किसी एंगल पे इंसिडेंट हो रही, देखो, तो फिर ये एंगल पे ही चली जाएगी ना वापस, यहाँ पे कोई एंगल बनाते हुए चली गई।
Yes sir.
ठीक है। तो अब मुझे ये बताओ कि अगर ये एंगल मान लो आई है, तो ये एंगल कितना होगा? देखो सुनो, बहुत अच्छे से सोच समझ के बताना, because it is very simple. That's why I'm saying that. At the first, think about it, then answer me.
Sir, आई होएगा वो भी.
हम्म,
आई होएगा वो.
सेम होगा क्यों?
एमनी आई, because it will be angle of reflection and angle of incidence is equal to angle of reflection.
Very good. As we know that in reflection, angle of incidence is equal to angle of reflection.
Yes sir.
So if angle of incidence is I, then angle of reflection is also I.
Yes sir.
मेरे ख्याल से यार ये रिफ्लेक्शन का टॉपिक आपको बिल्कुल क्लियर हो रहा है ना?
Yes sir.
ओके, अब सुनो मेरी बात आगे। अब आगे क्या हुआ? अब आगे ऐसा हुआ कि देखो ये जो येलो कलर या रेड कलर वाली ये जो लाइट थी, वो तो यहाँ से इम्पैक्ट होने के बाद वो वापस लौट गई, रिट्रेस कर लिया उसने अपने पाथ को। ठीक
Yes
है।
sir.
और ये वाली जो लाइट थी जो ब्लू कलर से आई थी, तो ये लाइट यहाँ से आई, इस पॉइंट से टकराई और फिर ये इधर चली गई। लेकिन हमको इमेजेस भी तो चाहिए। तो अब हम क्या करेंगे, सुनना, अब हम क्या करेंगे, व्हाट विल वी डू नाउ? अब हम इस लाइट को यहाँ पे आगे बढ़ा देंगे अपने हिसाब से। ये देखो डॉटेड से बढ़ा दिया, ठीक है। और इस लाइट को भी अब हम क्या करेंगे, यहाँ पे डॉटेड लाइन से इसे बढ़ा देंगे। तो ये दोनों लाइट देखो अब इस पॉइंट पे एक दूसरे को इंटरसेक्ट कर रही हैं, ठीक है। तो अब इस पॉइंट पे क्या बन जाएगा, इस पॉइंट पे हमारी बन गई एक इमेज, इस पॉइंट पे हमारी क्या बन गई, इमेज। अब इस इमेज को हम लोग क्या बोलेंगे, बताओ ये कौन से टाइप की इमेज हुई है, रियल या वर्चुअल?
virtual.
हाँ, वेरी गुड। तो ये इमेज जो होगी वो हमारी वर्चुअल इमेज होगी, दिस इमेज विल बी वर्चुअल। व्हाई दिस इमेज इज वर्चुअल?
Because the points are appearing to intersect, but they are
Yes,
imagined.
very good. Because the light rays are not intersecting each other in real. Okay, light rays are not meeting at a point in real. They are appear to meet. They are appear to meet. So when they are appear to meet, that is called virtual image. Okay, and I have told you before that one another property, when image is virtual, that will also be erect. If image is virtual, that will be erect also. Okay, so we are seeing that this image is erect also because this image is in the upward direction and object is also kept in the upward direction. Image is also formed in the upward direction. Okay, so virtual and erect, virtual and erect, everything is clear?
Yes, sir.
Okay, so now we'll move we talk about the characteristics of image formed by plane mirror. So what are the characteristics? First is virtual and erect. ये तो अभी प्रूव हो गया ना कि ये इमेज कैसी है, वर्चुअल है और इरेक्ट है। सेकंड क्या है, साइज ऑफ इमेज इज इक्वल टू द साइज ऑफ ऑब्जेक्ट, मींस इफ द साइज ऑफ ऑब्जेक्ट इज एच ओ and the size of image is hi, so we can say that hi is equal to ho. Hi is equal to hu, means height of image and height of object both are equal in this case in plane mirror. Okay, are you getting me or not?
Yes, sir.
Okay, now third point is image is formed as the far behind the mirror as the object is in front of it, means image जो है वो दूसरी साइड पे बन रही है, obviously virtual image है. Okay, consider that this is a plane mirror, this is a plane mirror. Okay, and this is the principal axis, this is object, this side is well polished because we are dealing with the plane mirror, so this side should be well polished. Okay, और मैंने अभी आपको ये भी बताया था एक चीज, अगर आपको अभी याद हो, मैंने लिखा भी था, राइटिंग में लिखा हुआ था कि अगर इमेज पॉलिश्ड साइड की साइड बन रही है, पॉलिश्ड सरफेस की साइड में बनी, इफ इमेज इज फॉर्म्ड एट द साइड ऑफ पॉलिश्ड सरफेस, देन इमेज विल बी वर्चुअल, इमेज वर्चुअल होगी, मैंने अभी बताया था, है याद आपको ना?
Yes, sir.
Okay, so now laterally inverted. अब laterally inverted means what? The right side of the object appears left side and the of the image and vice versa. मीन्स उल्टा होता है ना, जैसे हम अपना फेस देखते हैं जब मिरर में, तो जो चीज हमारे राइट में उसमें हमें लेफ्ट दिखाई देता है होता है ऐसा, तो वही उसी का मतलब है लेटरल इन्वर्जन, लेटरल इन्वर्जन. ओके, इज इट क्लियर?
Yes, sir.
नाउ look at this, look at this application of lateral inversion. What is lateral inversion? आपने एम्बुलेंस देखी होगी,
Yes, sir.
एम्बुलेंस में जब एम्बुलेंस सामने लिखा होता है, जब हम देखते हैं, तो वो क्या सीधा सीधा होता है एम्बुलेंस, ऐसा लिखा होता है कि एम्बुलेंस सीधा लिखा होता है?
No, sir.
कभी भी सीधा नहीं लिखा होता है, किस टाइप से लिखा होता है फिर?
Laterally inverted.
यस, इस टाइप से लिखा होता है, ये देखो दिखाई दिया,
यस सर।
ये चीज दिखाई दे रही है आपको, इसी टाइप से लिखा होता है एम्बुलेंस। जिससे
यस
कि क्या होगा कि जैसे एम्बुलेंस मान लो किसी गाड़ी के पीछे से आ रही है, और उस गाड़ी में देखा होगा अपने साइड मिरर होते हैं ना, साइड मिरर असल दो लगे होते हैं, कार में साइड मिरर होते हैं, बाइक में भी होते हैं, लगाने को लगा लो, बाइक में, कार में भी होते हैं। तो जब कार में एम्बुलेंस दिखाई देगा तो कार में एम्बुलेंस लिखा हुआ दिखाई देगा और बिल्कुल सीधा दिखाई देगा कि एम्बुलेंस, बिल्कुल कार में ऐसे दिखाई देगा कि यही लिखा है, क्योंकि वो उल्टा लिखा है ना रियल में। तो कार में हमें उसकी सीधी इमेज दिखाई देगी, मतलब काइट के साइड मिरर में। और अगर ये सीधा लिखा होता, जैसे मान लो कि ये ऐसा लिखा होता, एम्बुलेंस के ऊपर ऐसे लिखा होता, अब इसकी आप इमेज देखो कार के साइड मिरर में, तो आपको फिर ऐसा दिखाई देगा, तो ये आप पढ़ ही नहीं पाओगे कि यार ये क्या लिखा है। ठीक है, बात समझ रहे हो ना मैं क्या कह रहा हूँ।
यस सर।
तो इसीलिए एम्बुलेंस इस टाइप से लिखते हैं, जिससे कि साइड मिरर में अगर देखा जाए तो साइड मिरर में हमें वो बिल्कुल सीधा दिखाई दे, हम उसको पढ़ सकें, और फिर उसको हम साइड दे दें कि भाई हाँ तुम चले जाओ, तुम अर्जेंट में हो गए, जरूरी है तुमको जाओ, भाई किसी ना किसी को तो लेके जा ही रहा होगा एम्बुलेंस, तो तुम जा सकते, ऐसा। इज इट क्लियर और नॉट?
यस सर।
ओके, now we will talk about the spherical mirror. Actually we have discussed about the spherical mirror, so हम इसको थोड़ा जल्दी जल्दी कर लेंगे. There are two types of spherical mirror, concave mirror and convex mirror. Okay, the mirror whose outer surface, external surface is well polished, that is called concave mirror. Sorry, this is not a concave mirror. Wait. Okay, concave mirror is what? Concave mirror is what? This is a concave mirror. Okay, and the convex mirror is what? This is a convex mirror. Okay, एक्चुअली यहाँ पे यार ये गलती हो गई है, सुनो, ये मैंने डायग्राम उल्टे बना दिए इन दोनों के, ये कॉनकेव मिरर का है, समझ रहे हो ना?
यस सर।
हाँ वो गलती से हो गया, ठीक है। और ये कॉन्वेक्स मिरर का है, ये वो उल्टे बन गए, इसको थोड़ा देख लेना अपने हिसाब से ना।
यस सर।
ओके, ओके, नाउ we'll talk next. So okay, if we talk about the properties, if we talk about the properties of concave mirror, so there are some properties in the concave mirror. Reflecting surface is curved, obviously we know very well. Converging mirror, ये तो हमको सब पता है ना, ये तो सब हम जानते हैं, बेसिक प्रॉपर्टीज है। दूसरा क्या है, प्रॉपर्टीज ऑफ कॉन्वेक्स मिरर क्या होता है, रिफ्लेक्टिंग सरफेस इज कर्व्ड एंड डाइवर्जिंग मिरर, ये सब हमको पता है, ये रे डायग्राम है, ये सब हम जानते हैं अच्छे तरीके से ना।
यस सर।
हाँ, तो ये तो वेरी सिंपल है ना, बहुत ज्यादा सिंपल है, और ये हम वैसे भी कर चुके हैं पहले से, तो इसको हमें ज्यादा स्पेशल देने की जरूरत नहीं है। ये जो डेफिनेशंस लिखी हुई है, ये डेफिनेशंस भी हम पढ़ चुके हैं, सारे डेफिनेशंस वी नो वेरी वेल. What is
यस
principal axis? Okay, if you say, I'll explain in the figure. Okay, okay, I'm explaining the figure. Consider that this is a mirror. Which mirror is this?
कॉनकेव।
Okay, this is a concave mirror, and this line is known as principal axis. This line is known as principal axis. Okay, so what about this point?
फोकस।
No, not a focus. At the first, you have to focus in the diagram. At the first, you have to focus in the diagram. Which point
पोल।
is this? Pole. Very good. Okay. And if we talk about this point, consider that any light ray is incidenting on the mirror. This is the light ray incident on the mirror parallel to the principal axis. So it passes through a point after reflection. So this point is known as focus. This point is known as focus. Okay. and the distance between focus and pole of mirror, that is called focal length. That is called focal length. Okay. And this point is known as center of curvature. This point is known as center of curvature. Okay. And we
Yes.
draw a normal from the center of curvature always. Something like this. This is a normal we are drawing from the center of curvature. Okay. So tell me about this angle. What is this angle? This angle is what?
Incidence.
Angle of incidence. Very good. And what about this angle?
Angle of reflection.
Angular reflection. And as we know that I is equal to R. Okay. This is the law of reflection. Okay. This distance is known as radius of curvature. That is capital R. Radius of curvature means capital R. Capital R means what? Radius of curvature. Okay. So all the definitions are written. Principal axis is what? Pole is what? Aperture, center of curvature, radius of curvature, focus and focal length. Okay.
Yes, sir.
Now one more thing, relationship between the focal length and radius of curvature, that is f equal to r by 2. F is equal to r by 2. This is the relation between focal length and radius of curvature, that become f equal to r by 2. Okay. If the radius of any mirror, okay, listen, if the radius of curvature of concave mirror is 36 centimeter, this radius is for the concave mirror. Consider that this is the radius of concave mirror, that is 36 centimeters. So what is the focal length of the concave mirror? This is the formula which you have to use here. This is the relation between focal length and radius of curvature. If the radius of curvature is 36 centimeters, so what is the focal length?
18 centimeter.
18 centimeter. But I am talking about the focal length of concave mirror. Concave mirror. Negative. Focal length of concave mirror is
Negative.
always negative. Is it okay?
Yes.
Any problem? If you are facing, then ask me.
No, sir.
Okay. Now we'll move further. So look at this diagram. Look at this heading. Actually, heading is rules for making a ray diagram by spherical mirror. Okay. So रूल है, अब हमको बताने हैं